So, what is an audio signal? Audio means some things that you can listen, and signal can be taken as a waveform or pattern with variations. Let's say I have a signal y of t is equal to sine A 2 pift, where f is frequency of a signal. T is an independent variable that represents time, so this is a single-dimension signal as it involves only one independent variable. Let's plot this signal in MATLAB. To plot this signal in MATLAB, you need to first define the variable f, and f is a frequency in Hertz and is a constant number, let's say 10, which means 10 cycles per second. T represents time. We say start time is 0 and stop time is 5 seconds, and the step size is taken as 1 over fs. Fs is sampling frequency, which shows how many samples should be taken in 1 second. The Nyquist criteria says that the sampling frequency of signal should not be less than twice the maximum frequency present in a signal. This a whole different concept that we will study in another series later. For now, don't worry about it. And with this, we define sampling frequency as 30 times the frequency of a signal. Now we define the signal y of t in MATLAB. Sine A is a built-in mathematical function. We use that. As everything makes sense now, so we run this script. After running this, we can see that a number of variables corresponding to this script appears in the workspace. You can see the dimensions of each as well here. Be careful, and if something went wrong, do check that the variables defined exist in workspace or not. Semicolons are used to suppress the output of the line from the command window, or we can also use semicolon to write multiple commands in a single line. Now we plot this signal in MATLAB by using a plot command. The code for that is shown as well. We plot the y of t, which is a sinusoidal function with frequency f. The x-axis and y-axis are labeled properly along with font size enhanced. In 1 second, there exists 10 cycles, so it is difficult to visualize this signal at large scale of time axis, so we show 1 cycle here to see the signal. This is a periodic signal, so looking at 1 cycle makes sense. Don't worry about the periodic signal concept, we will study them later in another video series. Now we use the sound command in the MATLAB and pass this variable y along with sampling frequency fs to listen the sound. By running this command, we hear this sound. Boom, so we have done a lot, and now we know what audio signals are. It is just a vector of numbers with few properties like sampling frequency and various other parameters that we might see ahead. In fact, we have learned how to plot an audio signal in MATLAB. Remember that sound command needs 2 variables the data vector along with sampling frequency. If you run the sound command with different sampling frequency, then the sounds doesn't correspond to the real data. So always use the correct sampling frequency, which is the associated one with the signal. But we have always seen the sound files in MP3 WAV format. Okay, that is not a big deal. Let's say I want to store this in WAV format, I use the audio write function, and the file will be stored in the current folder directory, as shown here. This is all about audio signal. Stay tuned in next lectures of this video series. We will see how to record our own voice in MATLAB and how to do time and frequency domain analysis of that. After that, we will also take an audio music signal as an example to strengthen these concepts. Thanks for watching. Bye.